Hey, welcome back, my little Pythagoreans. We are going to talk about graphing today. I know, one of your favorite topics of all time. I've also moved the microphone a little bit closer to my face, so hopefully that helps with the volume a little bit. Some kids complain that, they couldn't quite hear me. I wasn't loud enough. So it's a little closer now. So if it's too loud, you're just never going to be happy, are you? So, all right, let's talk about graphing sine and cosine today. We'll do tangent a little bit later. It looks kind of weird, but these two are similar enough that I think we'll be fine. So, all right, let's kind of start with what we're going to do because our x-axis is going to look a little funky, and that's fine. You got to realize what's happening, okay? So, we are going to we'll start by looking at y equals sine of theta. So what we are going to do is we're going to change this a little bit just so it makes sense, right? So normally we have y equals something with an x in it, right? But for some reason, students get confused as soon as we start graphing sines and cosines. So we're going to graph sine, and theta is what you guys are used to going in sine, correct? But we need to just realize what we're doing with theta, okay? Theta is inside of sine. It is the input value. So we're going to pretend that y equals sine of x, okay? So on the x-axis, we are going to put our theta values, okay? We are going to do this in radians because it's better. I don't know. Something just feels weird about labeling this as like 30, 60, 90, 120. Something about this feels dirty, right? It feels like you just stuck your hand in a bag full of soggy bread or something. So we're not going to do it that way. We're going to use radians. So all we're going to do for right now is we're going to go around this circle, and we're going to write down all the multiples of 30 degrees, but we're going to use their radian measures. So we're going to use pi over 6, pi over 3, pi over 2, 2 pi over 3, and etc. We're going to skip these 45s because we want our x-axis to be evenly incremented. Right? You can't go 30, then 45, then 60, then 90. Do you see how you do plus 30, plus 15, plus 15, plus 30? This is bad. If you wanted to do it this way, these gaps right here cannot be the same size. Otherwise, you're kind of implying that they are the same gap, right? So we're going to skip these 45 ones because that messes up our axis. Okay, so let me just show you the axis and then we'll go, oops, that's not what I wanted to do. I love Smart Notebook so much. It's such a great program, you guys. Okay, so let me just show you how we're going to label this thing for right now, and then we will go graph this for realsies. Okay, so we're going to have pi over 6, pi over 3, pi over 2, 2 pi over 3, then 5 pi over 6, and so on. Okay. Likewise, we could go negative, right? We talked about negative angles, like this would be negative 30 degrees if we went that way. We can definitely look at what sign there is or the y value there. So we can also go in the negative direction. So we do negative pi over 6. I think I erased the tab there. Negative pi over 3, negative pi over 2, and so on. So this does not look evenly incremented, but it is. I think that's maybe why students have such a tough time with this scale. So this is the x scale we're going to use for right now. We might change it later if we think it's too wide or too narrow or something. But for right now, just realize when I label our axis like this, It's because we are taking evenly spaced angles from around our unit circle. And the reason we are using these pi's is because the input of our function is theta, and theta is measured in radians. Okay. All right, so let's graph sine. I don't know that I necessarily needed a whole new slide for this, but you know. All right, so we got pi over 6, pi over 3, pi over 2, 2 pi over 3. I'm only going to do the positive, and then we'll take a peek at the negative. Okay, there's pi. 1, 2, 3. Wait, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this would be 2 pi. Let's see. This is 7 pi over 6. This is 4 pi over 3. Let's see. 3 pi over 2. And, oops, that one's got to move. I counted wrong. Sorry. 5 pi over 3. And then 11 pi over 6. Okay. So we are looking at all of these angles. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and then 2 pi is 360. So this is the full rotation all the way around. Because we are looking at sine, we're going to go grab all of our y coordinates from these ordered pairs, right? Because sine of theta equals y. So we're just grabbing the y piece. Okay. So our input is the angle. Our output for sine is the y value. And it just happens to be the variable y here. So let's go around the circle and grab our values. So at 0 degrees, y is 0. So we're going to start at 0. Awesome. At pi over 6, we're at a half. I'm going to make this 1/2 and then 1, 1.5, 2, just to spread it out a little bit. So we're going to go over to pi over 6, up a half. At pi over 3, we are at radical 3 over 2. So what we're going to do is I'm going to convert that to a decimal just to make it a little bit nicer for us to try and graph. As a decimal, radical 3 over 2 is 0.866. Okay, so almost 90% of the way to 1. Okay, so we're going to go over to pi over 3, up a half. Half past that would be another quarter, so that would be 0.75. So we need to be a little higher than that even. So we'll put it right about there. Okay, it's not going to need to be perfect. At pi over 2, we're at 1. Then after we pass here, we can see that our y value starts to go back down. Now it repeats these values, but in reverse order. So we're going to go back to 3 pi over 2. So it should be the same height as that one. Then at pi, whoops, dang it, I messed up again. I skipped one. Scoot those all down. My bad, you guys. I'm sorry. I skipped 5 pi over 6. Okay, at 5 pi over 6, we're at a half. Then at pi, we're back at 0. Okay. Now, once we go past pi, we start using these same values again, except now they're negative. So we're going to go to negative a half. We're going to go to negative 0.86. We're going to go to negative 1, negative 0.86, negative a half, and then back to 0. So this is one full rotation around our unit circle. So our our sine graph is going to start at 0, come up to 1, curve back down. Whoops, I missed a little bit. Curve back down to 0, and then do that same curve, but a little bit reversed upside down. Okay, Okay, now you're going to say, Mr. Barton, what happens if I keep going? What if I add another 6th of pi? If I go another 30 degrees? So you can do that. This would be 13 pi over 6. That is coterminal with 30 degrees, or pi over 6. So what that means is it has the same sine value, or the same y value. So we just go back up to a half. If you keep doing this, this graph will repeat forever. It'll do that. Likewise, if we do negative values, if we go to negative pi over 3, or pi over 6, which is negative 30, we're at negative 1/2. So we go left, down a half. Then if we did negative pi over 3, or negative 60, we'd be at negative radical 3 over 2. So we would be at almost negative 1. Then at negative 90 degrees, we'd be at negative 1. So you can see this curve pattern continues into the negative direction and would keep doing this waving thing. So sines are sometimes called sine waves because they make this nice repeating wave that continues forever. Awesome. Cool. So that's what sine looks like. This is what we would call the parent function, because this is the most just like basic sine function you can have. There's nothing weird about this. It's just the math operation we're interested in with x. There's no plus anything. There's no squaring. There's no multiplying by anything. It's just the math operation we're interested in. So this is called the parent function. We're going to use this to make all of the other sine graphs. So I want to point out a couple of really important features on this graph to you guys before we go look at cosine. It's super similar, but there's some important features here that you should know because it'll make graphing this a lot easier and a lot faster for you. The first thing we should know is that sine of 0 equals 0. That point right there. This point should kind of always occur for a sine. If you stretch this, so if it were like twice as tall, this point would still be exactly where it's at. Okay, so one thing you want to know is sine starts at 0. Okay, the other thing you want to know is that because we are making this function based off our unit circle, and a full spin around the unit circle before it repeats is 2 pi, our graph will repeat every time we go 2 pi. So we'll go this whole thing, 2 pi. So we have a full up, right? A full top hill. We have a full bottom, or completed valley, and then it repeats again. We have hill, valley. On this side, we have the valley, and then if we have more space, you would see the hill. Every time this repeats, the width will be 2 pi. So from here to there, that is 2 pi. There's a special word for this. This thing is called the period. Kind of like hockey, I guess. Period as in like a set amount of time, or periods in class. One full period of math, or one full period of sine is 2 pi. Okay. There are ways to change this, but it's going to be the same thing for this whole lesson. It should always be 2 pi. Okay, so full period is 2 pi, because that's a full circle. Two more things that I would just like to bring to your attention is that our graph never goes above this line. All right, here's the highest it ever gets is 1. That's because the largest number we ever see on the unit circle is 1. And likewise, it never goes below this line. And this is at -1, because the smallest number you ever see on the unit circle is -1. So these are our maximum and our minimum for this graph. Okay? So a lot of information, but it'll be fine. All right, let's go look at our cosine graph. Actually, let me see if I can do this in an intelligent way so you don't have to sit and watch me label stuff for like an hour. Let's move some of this stuff out of the way. I'm going to see if I can just copy these. Ooh, you bet I can. Copy. Paste. There we go. Okay. All right, so we are going to graph cosine now. Let's do maybe blue. Let's make it a little skinny. Okay, so we're going to graph y equals cosine of x now. And remember, x is just the angle. And again, we're going to do all the multiples of 30. So we're going to do 30, 60, 90, 120, and so on. Remember, cosine goes with the x value of these ordered pairs. So when we are at a specified angle, we're going to look at our x value to find our value for cosine. Again, I'm going to do a 1/2 and then 1 and then negative a half, negative 1, just so we can space it out a little bit. So at 0 degrees, we start at a 1. So cosine of 0 is 1. That's a little bit different than sine, but that's okay. As we go up, we start at the big value, radical 3 over 2, which remember is about 0.866. So almost a 1. So we'll go down a little bit, go over. There's our 0.866. Go to 60, we're at a half. At 90, x is 0. So at pi over 2, you should be crossing the x-axis. Going another 30, we're at negative a half. So we're going to the negative side now, down a half, down 0.866, so almost negative 1. And then at pi, we are at negative 1 on the x-axis. There we go. Okay. Then you can probably tell this is going to just curve back up. So we're going to go negative 0.866 again, negative 1/2, 0. Okay, so there we go. Negative 0.866, negative a half, 0. Now positive a half, positive 866, and back to 1. So positive a half, positive 8.66, and positive 1. So here is our cosine graph. Let me see if I can draw straight through all these. Okay. So a couple things we can compare to our sine. We can see our maximum is still at 1. It also starts at 1 instead of starting at 0. It has a maximum of 1 again. It has a minimum of negative 1. And it repeats at 2 pi just like sine did. Okay. So you're going to say, wait, does it have the full up and the full down? So let's look. Here we have basically the right half of a hill. So we have half of the upper section. We have the full lower valley. And now we have the left side of the hill. So this piece here and this piece here make the full hill. So we have a completed upper section. Look, we could even take, oh no, we can't. Sure we could. Watch this. There we go. So we could take this over here. Boom. There you go. So we have the full upper section and the full lower section. So we do have a full period of our cosine. Okay. All right, and that's the graph of cosine. So it starts at 1 instead of starting at 0. It goes down to 0, lower section, crosses again, comes back up to 1, and then, of course, this would repeat just like sine did. So this would go 0.86, a half, 0, and it would do that. This side also does the same thing. It does the 0.86, a half, 0, and then it would continue doing the same oscillation. So this thing, of course, does keep going forever. So it's going to wave, wave, and keep going forever. Cool? All right. So let's talk about some vocabulary really quickly, just to make sure that you caught everything. So we have maximum values. These are the largest y values on our sine and cosine graphs. So let's draw a sine graph. Ooh, that's ugly. Let's try that one more time. Okay. Our max is just whatever that spot is, whatever that spot is. There's like an invisible line that it won't cross. Okay. Our minimum is the lowest y value. So lowest value right there. There is also an invisible lower line, and our graphs will be kind of sandwiched between these two. Our period is the horizontal width of one full cycle, or one full up and one full down. It should have both for your graph. This is not drawn super well, but from here to here, so we have full up, full down. This width right here should be 2 pi for today. We'll change this later, but for right now, the default is 2 pi. You might want to write that down. Default is 2 pi. Okay. And then there is one more vocab word that we're going to talk about today. It is the midline. So the midline is an invisible horizontal line. It's a third one that the graph oscillates around. It's halfway between the maximum and the minimum. Okay. So if our maximum is at 1 and our minimum is at -1, halfway between that would be 0. So this invisible line is called the midline. It is exactly in the middle of your maximum and your minimum. That's why it's called the midline. It's going to make it a lot easier for us to graph. It's just a handy thing to find because it makes your life a little easier. Okay. All right. So let's go talk about ways we can transform this graph, because if I just say, all right, now you graph sine and you graph cosine, well, you've already got them. That's them. That's the graph, right? It'd be like if I taught you y equals x plus 1 and then said, okay, you graph y equals x plus 1. Well, you've already seen it. You need to graph something different. So let's talk about ways we can translate the graph. We're not going to stretch it out and make it like really tall like this. These are so ugly. Oh my gosh, why are my signs so pointy? But what we're going to do is we're going to take our regular sine graph and we're going to maybe, there we go. We're going to maybe shift it up so that it's always positive. Or maybe we'll take it and then we'll shift it a little bit so that it doesn't start at 0 anymore. We're going to worry about vertical and horizontal shifts today. So like every other math operation you have ever learned about, if you do something to the x inside the math operation, that will cause a horizontal shift. And just like every other math operation you have ever seen in this class or any other algebra class you've ever taken, whatever sign this is, you do the opposite of that. Okay? So what that means is if it says like +3, you're going to go left 3, even though left is negative, because the sign is reversed for your horizontal shift. Also, like every other math operation you've ever seen up to this point in your life, K is responsible for your vertical shift, And that's going to just move our graph up and down however far k says. And if it says plus 2, it means go up 2, go in the positive direction 2. K's sign is not reversed. Okay. The one thing I will caution you about is that h is probably not going to be like 3. It's probably going to be more like pi over 4. Or it's going to have a pi in it probably, because we are graphing our x-axis in terms of pi, or in terms of radians, which have pi's in them. So it's actually easier to graph it that way instead of having 3. Because if you want to go 3, here's pi. This is 3.14. How are you going to find exactly 3 on this line? It's, I don't know, like right there somewhere. So you'd have to move it just slightly to the left, right? It's easier to do it in fractions of pi because that's the way our axis is going to be labeled. Okay. So let's look at this first example. Let me go ahead and rewrite my x-axis, and then I will copy it and lock it down so I don't have to do it ever again. Okay. So we're going to do pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6. We're almost there. We're getting there, you guys. I apologize. I should have done this ahead of time. 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and then 2 pi. And then just for good measure, I'm going to do 13 pi over 6 as well. Okay, on the left side, we'll do negative pi over 6, negative pi over 3, negative pi over 2. What's the next one? Negative 2 pi over 3, and then negative 5 pi over 6. Okay. All right, let me go ahead and copy these. Thanks. You guys are super patient. I appreciate it. Put these over here where they belong. Copy these. Put them over here where they belong. All right, and we're ready to go. Okay. All right, so we are going to go ahead and graph sine of x minus pi over 2 minus 3. So this thing is going to shift our graph right pi over 2. Okay. And then this thing is going to shift our graph down 3. Because my graph isn't necessarily going to be set up, if I do it with the 1/2, so half, negative 1, negative 1.5, negative 2, I'm not going to have enough room. So let's label our y-axis in terms of 1 this time. So we'll have 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. All right. So let's start with our parent function, and then we will do our transformations. Okay. So the sine graph, you should pretty much just go ahead and memorize it. It starts at 0. Then every time you go over 30, you're going a little bit farther around your circle. And it kind of makes sense, right? It goes 0, a half, 0.866, 1, 0.866, a half, 0. Oops, why did that right? 0, a half, 0.866, 1, and then it just repeats this backwards, 0.866, let's do 0.5, I guess, for a half, 0, and then repeats in the negative direction. So then you'd have negative a half, negative 0.866, negative 1, negative 0.866, negative 0.5, 0. And then it just repeats this pattern forever, over and over. So it's worth kind of memorizing just what those are. It makes graphing pretty fast. So 0, a half, 0.866, 1, 0.866, a half, 0, negative a half, negative 0.866, negative 1, negative 0.866, negative a half, 0. So our parent function is going to look like that. Now what we need to do is we need to take this whole thing and move it right pi over 2. So pi over 2 is right there. That's 1, 2, 3 tick marks. So all of these points are going to shift right 3 tick marks because of the way we have this labeled. Then they're going to go down 3. So let's do it in green. Okay. So this one, we're going to go down 3 and then right 3 tick marks because every 3 tick marks is a pi over 2. So we're going to go 1, 2, 3, 1, 2, 3. That's where we're going to start. Something that's helpful to know. This k value, k equals your midline. So here's our midline at negative 3. And then normally we start at 0. Normally, right? That's what our parent function here is. Because we are shifting to the right pi over 2, that's just basically telling us if we took this thing, come on, and we went 1, 2, 3, now we're just starting that same graph at pi over 2. So you're going to start at whatever your h value is. So start at, pi over 2 because h equals pi over 2. Okay. So here at pi over 2, that's our new starting point because of this number right here. And instead of starting at 0, we're going to start at negative 3 because of k. So start there, and then you follow this same pattern, pretending this is 0. So our next one over, you would go up halfway from the midline, or half of a unit from the midline. So you go over, up a half. Over, up to 0.866 above the midline, so about right there. Over, 1. Over, back down to 0.866. Over, a half. Over, back to quote-unquote 0, or back onto the midline. Then we just repeat the same pattern going negative. So we go down a half, down to about 8.66 from the midline, down to 1, back up to 0.866. Whoops, that should be over a little bit more. And right there. Back to a half, and then 0. Right about there. Okay, so this green line is y equals sine of x minus pi over 2 minus 3. What we've done is we've taken our parent function, shifted it to the right pi over 2, which is 1, 2, 3 tick marks, as we can see right here. And then we've taken it and gone down 3. Right? So we could even count. We could go 1, 2, 3, 1, 2, 3. Oh, that one lines up. 1, 2, 3, 1, 2, 3. That one lines up. Okay. So that's pretty much how you graph it. Let's go ahead and look at a cosine one. Okay. For this one, I'm not going to graph the parent function, and we're just going to go straight into graphing this. Okay. Our midline is going to be at y equals 2. It's going to be a horizontal line. Here, let's even undo that. Undo. Let me get a real horizontal line. Dashed. Let's make it blue. Okay. This is our midline. Okay. Our maximum is 1 above that and 1 below that. So let's put those. Let's do that. Let's make this blue also. Okay. So our maximum is going to be 1 above that. And then our minimum will be 1 below that. Okay. Okay. So here is our midline. That's our quote-unquote 0 because of this vertical shift of 2. We also need a horizontal shift of pi over 3. So that is 2 tick marks, because there's pi over 3. Because it's plus, we're going to go left 2 tick marks, if that makes sense. Okay. So instead of starting at 1, 0 for cosine, that's what the parent function is, we would start at the maximum, and it would be on 0, but we need to go left 2 tick marks. So 1, 2, start there. Now we just follow that pattern of 1, 0.866, 0.5, 0, 0.5, 0.866, 1. And then, of course, the negatives. We follow this pattern to get the rest of our points. So we have 1, which is also your max. Okay. Then we go down a little bit. So we go over 1, down a little bit. Over 1 more, down to a half. Over 1 more, down to 0. Okay. Whoops, sorry. These should be negative. Over, down a half, over, almost to -1, over, -1, over, 0.866, over a half, over 0, or back to the midline, over, up a half, over, almost to 1, over, up to the max, and then there is our, whoops, hang on, that's abysmal. Let me try that one more time. And there's our sine or cosine wave. You could keep repeating this pattern. So we're at a max, over, down to 0.866, over, down to a half, over, back to the midline, over, down a half. And then you could just use that pattern to keep continuing your graph in either direction. And there you go. That's graphing sines and cosines. So I recommend start by looking for your midline. That will tell you where your new 0 is, quote unquote. Cosine starts at a max. Sine starts on the midline. Then just remember your H has the sign reversed. Okay. Hopefully, oh goodness, you guys are going to be so cranky. 39 minutes. I apologize, you guys. Honestly, it's not as bad as it looks. But if you need help, let me know. See you guys next time.